Good morning, students. Today we are going to study about Newton's equations of motion. Newton studied the motion of an object and gave a set of three equations of motion. These relate the displacement, velocity, acceleration, and time of an object moving along a straight line. The three equations of motions are v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. These are the three equations of motion. We are going to derive all the three equations by graphical method. So let us derive Newton's first equation of motion. So this is velocity time graph, time along the x-axis and velocity along the y-axis. Consider an object starting from the point D with initial velocity u. The object starts from the point T in the graph. Its velocity keeps increasing, and after time t, it reaches the point B. So, this is the final velocity of the object. To get the final velocity, we will join this point to y-axis, as we know that velocity is along the y-axis. So the point C is final velocity. Final velocity is denoted by the letter V. And initial velocity is denoted by the letter U. From the graph, initial velocity of the object is equal to OD, and it is denoted by the letter U. And final velocity is OC. This is the final velocity, and it is denoted by the letter V. The time is on the x-axis, and the time taken by the object is OE, that is equal to T. Now, we know that acceleration is equal to change in velocity upon time. Change in velocity upon time. What is change in velocity? That is, acceleration A is equal to change in velocity means final velocity minus initial velocity upon time. Initial velocity upon time. Okay. That is, A is equal to, from the graph, what is final velocity? OC. So instead of final velocity, we can write OC minus, what is initial velocity? OD upon time t. Okay. That is equal to, now look at the graph, OC minus OD. But we will get OC minus OD, we will get this portion, that is CD. So we can write A is equal to CD upon T. On cross multiplying, we will get CD is equal to AT. Let it be equation number 1. Okay. Now, again look at the graph. A line parallel to y-axis passing through the point P is drawn. I have already drawn this line. This line is parallel to y-axis and passing through the point B. So from this graph, BE is equal to BA plus A. So we can write from the graph, BE is equal to BA plus A. Okay. And we know that B A is equal to CD and AE is equal to OD. Okay. So instead of BE, we can write BE is equal to CO. What is CO? That is the final velocity. So we can write final velocity is denoted by the letter V. That is V is equal to BA plus A. BA is equal to CD. So from equation number 1, what is CD? AT. That is AT plus AE. AE is equal to OD and that is equal to initial velocity. It is denoted by the letter U. Rearranging this equation, we will get V is equal to U plus AT. This is Newton's first equation of motion. V is equal to U plus AT. This equation describes the relationship between velocity and time. Now, two more equations are there that we will derive in the next video.